Hello students, in the last video which we had seen about the comparison of means of two large samples. Okay, now in this case, we'll be looking for the comparison of means of two small samples. Now I repeat this again that the difference between large sample and small sample is that the sample size. In case of large samples, the sample size is greater than or equal to 30, and small samples means the sample size is less than 30. Okay, so even in the last video which we had seen, for the comparison of means of two large samples, the two samples which were taken were independent of each other. Okay, now in this case also we are looking for those samples which are independent of each other. Okay, so independent small samples. Now in this case there is independent small samples, one part is there, and similarly when the samples are related to each other, there is just some dependency between the two samples. That time how to calculate the means or how to compare the means of those two, that is a second part of this video. Okay, so in this case let's focus on the independent small samples. Now this independent small samples, when two sample datas are given or two sample datas are given, for example this example. Okay, some x1 values are given, x2 values are given. Okay, we need to calculate the variance of that variance. Now in this case the variance has been defined in some other way, that is now pooled variance. I had defined about a pooled variance, that when we adjust a pooled variance according to our requirement, or let's say when we combine the two samples and we take the variance, it is called as pooled variance. Okay, so now in this case the variance of our first sample is given by this s1 square, that is variance will be summation x1 square minus summation x1 the whole square upon n1. Now n1 is what? Now suppose there are two samples, sample A and sample B. Okay, let's say these are my xy's, x1, and these are my x2 values. Okay, now the number of observations of this are my n1 and the number of observations of these are my n2. Okay, so this s1 square variance, pooled variance, is given by this x1 square upon summation x1 the whole square upon n1 divided by n1 minus 1. Similarly, s2 square, summation x2 square minus summation x2 the whole square upon n2 divided by n2 minus 1. Okay, these things you will have to remember. And then the pooled variance is given by this. Okay, so we'll be making use of this formula only, pooled variance. Okay, that is what this is, the only the numerator part of the s1 square plus the numerator part of the s2 square divided by n1 plus n2 minus 2. Okay, so this formula you will have to remember somehow. Okay, even if you forget these two formulas, it's fine. You need not calculate the s1 square and s2 square separately, but you need this formula sd square. Okay, and once this formula has been found, we will substitute in our test statistic. Now the test statistics is given by this: t is equals to mod of x1 bar minus x2 bar, that is the mean of sample 1, this is the mean of sample 2, divided by the standard deviation or the pooled deviation. Okay, sd square is the pooled variance. Now the deviation is what? The root of variance. Okay, therefore this is sd into root of 1 upon n1 plus 1 upon n2. Okay, now degree of freedom is given by this n1 plus n2 minus 2. Okay, that is this. It comes into this part. Okay, this is my degree of freedom. Okay, now you will look for the degree of freedom part and then you will compare the values from the table as we used to do for the earlier examples. Okay, let us be clear about this from the example. Now, for any example given, calculating this n1 is easy. That is just counting the number of observations. Calculating this n2 is easy. Okay. Then calculating x1 bar and x2 bar is also easy. Why? Because it is just calculating the mean of that, of those two datas. And now only question will be about finding this pooled variance or the pooled standard deviation. Okay, now once you found out this, test static, substituting in the test statistic and finding the data. Let's see this example. Now the example given here gives some two datas. Okay, sample A and let's say sample B. Now in this case these values are given for this. Okay, for sample A 2.9, 3.1, 3.5, 3.4, etc. And for x2 also 2.7, 2.8, 3.0, some values are given. Okay, now what I need is, I need to first calculate n1 and n2 sizes. Now here, in this case if you look, n1 and n2 both are equal in this case. Okay, that is what, 1 2 3 4 5 6 7 8 9 10, 10 observations. Okay, so for sample A and for sample B, the observations are, number of observation n1 is equals to 10, also for sample B n2 is equals to 10. Okay, now my next step is writing the null hypothesis H naught. Okay, null hypothesis H naught is what? There is no significant difference between the means of two samples. There is no significant difference between the means of two samples. Now, once this H naught has been calculated, what else we need is x1 bar, that is the mean of this sample A, and what we need is x2 bar, that is the mean of the sample B. Okay, now how to calculate this x1 bar? X1 bar will be what? Summation of all those xi's of this first sample, that is 2 divided by n1. Okay, so that will be what? Summation of all this, that is 2.9 plus 3.1 plus 3.5, that is the summation of all these, comes out to be 34.6. Okay, divided by n1. N1 is what? 10. Therefore my x1 bar will be 3.46. Similarly my x2 bar, for x2 bar what I will do? Summation of all x2's divided by n2. Okay, this n2 is again 10, as we have seen. And now if I add this 2.7 plus 2.8 plus 3.0 plus 3.5 plus this, all these 10 numbers, my final answer will be 30.7. That is, this comes out to be x2 bar comes out to be 3.07. Okay, so now I have got x1 bar, I have got x2 bar. So from this test statistic T, I have this value with me, I have this value with me, I have this value, I have this value. Now, next step is calculating the pooled variance or the pooled standard deviation. Okay. Now for calculating this, I will need more columns, that is columns of x1 square and x2 squares. Okay. So I have my x1s here. Okay. I have my x2s here. Now I need x1 square, I need x2 squares. Okay, this is for sample A, this is for sample B. Now x1 square, I have 2.9 is my first value, 3.1 is my next value. I can calculate easily x1 squares. Okay, similarly I have x2 values, I can calculate x2 squares. So I'll just write down what the values are. Summation x1, that comes out to be 34.6. Okay, this x1 square summation, this comes out to be around, I guess, 121.52. If you check, you will get these answers. Okay, similarly x2 square, summation x2 square, it comes out to be 95.17. And this summation x2's, what you get is 30.7. Okay, this we have seen. Okay, so all these values you get. Now once you have got these values, It is easier to calculate the square. SD square is given by what? Summation x1 square minus summation x1 the whole square upon n1 plus summation x2 the summation x2 the whole square minus summation x2 the whole square upon n2 divided by the degree of freedom, that is n1 plus n2 minus 2. Okay, so now once this has been found, this SD square, once you substitute all the values, the pool variance SD square, what you get is 0.15. Okay, this n1 plus n2 minus 2 will be, n1 will be 10, n2 is 10, and this, so this degree of freedom will be 80. Now SD square you have found, that is variance you have found. So SD will be root of 0.15, and that comes out to be 0.39, the approximate value. Okay. So now once you have calculated this all, you can substitute in test statistics. Now test statistics is what? X1 bar minus X2 bar divided by SD into root of 1 upon n1 plus 1 upon n2. So I have all these values. X1 bar I have 3.46, x2 bar I have 3.07, SD value which I have calculated is 0.39, root of 1 upon n1 I have, n1 is 10, n2 is also 10 in this case. Okay, so if you solve this further, it will come out to be around 2.44. 44. Okay, you can just verify these answers. Okay, now this 2.44, once you have got this, now you need to say whether there is a significance difference between this or not. Okay, at suppose level of significance, any level of significance you can choose, that is suppose 5% or 1%. Let's check at both. Okay, now this 2.44 is my calculated value. Okay, and now once I have this degree of freedom, I will go for the tabulated value. Let's see what is the tabulated value of this at 5%. Okay, this is the table I have. Let's check the degree of freedom. Degree of freedom is here 18. Okay, at 5% level, so at 5% level, it is 2.10 is my tabulated value. At 5%, 2.10. Okay, and at 1% it is 2.88. 1% it is 2.88. So let's go and check this. So what is my value? 2.44. So at 5% level of significance, okay, my tabulated value was 2.10. Okay, and this 2.44 is surely greater than this 2.10. Yes, so I can say that at 5% level of significance, my null hypothesis is rejected. Okay, that there exists a significant difference between the two. Okay, two sample means at 5% level. Okay, now similarly, if you check at 1%, it was 2.88. So at this point, 2.88, this calculated value at 1% level, it is 2.88, the tabulated value. So the calculated value is less than this 2.44. So you can say that at 1% level of significance, there does not exist a significance, means that is what the null hypothesis is accepted at 1%. At 5% it is rejected, at 1% it is accepted. Okay, I just wanted to show you this difference between the two, that is at 5% it is rejected and at 1% it is accepted. So that is the only reason I took both the levels of significance. Okay, so either you can take the one which has been mentioned in the question, or you can choose any one of your choice for this level of significance tests. Okay, so this is how we calculate the, or this is how we compare the means of two small samples of the independent small samples. Okay, let's move for this, the t-test for paired samples. Now previous were the samples which were independent of each other. Okay, now there can be the samples which comes in pairs. Like for example, if we want to compare the blood pressure of a patient before food and after food. Okay, so now these datas will come in pair. Okay, if I want to compare the blood pressures of various people before food and after food, now for that one particular person, the blood pressure data will be in pair. One data will be before food, one will be after food, that is it will be in a pair. Okay, as such kind of data they are called as, there exists some correlation between them, that is they are not independent, it is basically the thing that they are paired. Okay, one and the same. So now in this case the null hypothesis will be the mean of the difference between the pairs is 0. That is, suppose this is x1 data, suppose like in this case x1 data is about before food, blood pressure value before food, and this is after food, suppose. Okay, then this will be x1 bar, this will be x2 bar, the mean value which we get. So this is what the mean of the difference between the pairs is 0. It is the difference between this. So we'll be calculating one more column for any given data, that is x1 minus x2 column, or we'll say the difference column. Okay, and whatever we are calculating here, my null hypothesis is the mean of that x1 minus x2 bar should be 0. Okay, that is my null hypothesis. Okay, so in this case, my test statistic T is given by D bar. D bar is what? The mean of the difference between the pairs. Okay, into root n. Now, since these values or these sample sizes they come within a pair, that means the number of that my n1 value and n2 value will be equal, that is n. The sample size of both the data will be same. Okay, divided by the standard deviation. Now this standard deviation SD, in this case it is defined in slightly different way. Okay, so it calculates around summation d square, that d is the difference between the two samples, that is x1 minus x2. Okay, summation d square minus summation d the whole square upon n divided by n minus 1. So in this case we know the degree of freedom is my n minus 1. So now once these things have been known, the rest things follow as we were following in the previous. So let's see this example. Okay, so this example lists out the various rainfall data at region A, that is place A and place B, in this 10 years. Okay, so in 1971 at place A it was 177.79 mm of rainfall. Obviously this will be mm. Okay, the average rainfall was 177.79, and similarly at place B it was 69.79 mm. Okay, in 1972 it was at place A it was 146.12, at place B it was 103.93. Okay, so basically if you see this data have been in pairs, since I need to compare for each year, this data is within the pairs, that's why this paired samples we call this. Okay, so now my first step is, now this, for this place A I will call this as my x1 values, This place B will be my x2 values. Okay. So now I need to calculate the third column of the difference D, that will be given by x1 minus x2. Now if I need to calculate this, 177.79 minus 69.79, that comes out to be 107.50. Then this difference, 146 minus 103, that comes out to be 42.19. Then this is 85.60. Then this one is higher, so this one will go in negatives, that is some 11.53, then 5.47, 52.23, 59.45, 8.94, 35.50, and again this one will be in negatives, that is 2.42. Okay, so now this D value have been calculated. You need to calculate the D square values. Okay, so now once these values have been calculated, you will have summation D, you will have summation D square. Okay, so first thing is calculating D bar. D bar will be given by summation D upon total number of observations, that is n. Now total number of observations are 10 here, so n is equals to 10. Okay, and with n is equals to 10, you know the degree of freedom, n minus 1, that is 9. Okay, so now with this summation D bar will be what? Summation D upon n. Summation D comes out to be 382.93 upon 10, that is 38.29. This is my D bar. Now if you calculate this sum D square, summation D square will be given by 28434.76. Okay, so with these values you will be able to calculate SD square, that is summation D square minus summation D the whole square upon n divided by n minus 1. Now summation D square is this value which we have found, that is 28434.76 minus summation D the whole square, summation D, that is this is my summation D, 382.93 the whole square, 382.93 the whole square divided by n is my 10, the whole divided by n minus 1, it is 10 minus 1, 9. So whatever value you get will be your pooled variance in this case. Okay, so SD square, in this case this comes out to be 1530.14. You can verify these things. Huh? Now with this value SD square I have, so my standard deviation will be root of that 1530.14, and this comes out to be 39.12. Okay, so now once these values have been known to us, known to us, it is easy to calculate this. Okay, null hypothesis is standard, that is the mean of the difference between the pairs is 0. Okay, so once you write that at h naught, it will be same, the mean of the difference between the two pairs is 0. Okay, that will be as it is. So my t test will, or t test statistic will be d bar upon root n upon standard deviation. Now d bar I have, my d bar is given by 38.29. So 38.29 to root n. Root n is root 10 and standard deviation is 39.12. Okay, so whatever this value, I think this comes out to be 3.10. You just need to recheck this. Okay, this value comes out to be approximately 3.10. Okay, so this is my calculated t value. Now let's see what will be my tabulated t value. My degree of freedom, I have seen that my degree of freedom is 9 in this case, that is my n minus 1. So let's see what my tabulated t value is saying. Now tabulated t value at degree of freedom equal to 9, at 0 or 5% level of significance it is 2.26, at 1% it is 3.25. Okay, so at 5% level of significance, so at 5% level of significance it is 2.66. Okay, the tabulated value. So that means what? My calculated value is greater than my tabulated value. That is what? My null hypothesis is rejected at this 5% level, it is rejected. Now, similarly, at 1%, it was around 3.25. Okay. Now, in this case, 3.10, that is the calculated one, is lower than this 3.25. Therefore, at this place, my null hypothesis is accepted. Okay, this here just you need to mention. So this is the thing. This is how you solve this kind of examples. Now in this case only my unit 2 has been finished, almost finished. Only the part of ANOVA has been remaining. ANOVA is analysis of variance. Within one video I can finish the both the parts of that analysis of variance part, that is ANOVA, that is one way and two way. That is, these are the two cases of those ANOVAs. Okay, and with this I will be finishing unit 2.